Before proceeding with the declaration, it is more pronounced and persuasive to determine the subatomic gas pedals. The LHC, or Large Hadron Collider, worked, a 17-meter-wide superconducting ring created by CERN magnets. Furthermore, it is the world's most important and prominent particle smasher. It represents the zenith of human achievement. In actuality, it is so powerful that it can replicate the exact conditions of the first second of the universe. However, could a machine designed to reveal the mysteries of the universe hold the key to something genuinely extraordinary? Established in 1954, CERN is regarded as one of the most renowned research institutions, with 23 member states and numerous scientists. It is a hub for collaboration and innovation. The LHC is CERN's primary endeavor, but it is only one component of an extensive system of accelerators and experiments. Think of it as a racetrack, not for people or engines, but for subatomic particles. During a speed test of energy in space's very fabric itself, protons are accelerated to nearly the speed of light and sent on a collision course. These collisions mimic the energy conditions of the universe just after the Big Bang and create temperatures far hotter than the center of the Sun. A massive number of protons are guided by magnets on their journey, while complex cooling systems keep the magnets at temperatures lower than space. The proton beams in the LHC collide at 4 locations around the accelerator ring, corresponding to 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a distinct function, exploring various facets of particle physics. Together, they act as massive cameras, taking photographs of these collisions. Afterward, scientists sort through the resulting particles, looking for clues, phenomena like the mysterious Higgs boson, also known as the God particle, and others that could provide insights into the universe's fundamental building blocks. By focusing on the microcosm, we gain knowledge about the macrocosm. Yet, with every answer comes a new question. With every discovery, another challenge arises. The LHC isn't just a scientific tool, it's a testament to human curiosity and progress. It embodies our quest to comprehend the fundamental forces that shape the universe. However, as we push the limits, we must also take into account what we already know, the deeper and more existential questions that arise. What are the risks of probing the unknowable? Could our efforts to gain knowledge inadvertently unleash forces that are sacred and beyond our control? In halls where human boundaries and knowledge are constantly tested, a revelation has emerged that has left even seasoned scientists uneasy. Brian Cox, a former scientist at CERN and a prominent voice in particle physics, recently issued a statement that astonished and fascinated the world. His words have a chilling clarity. The Large Hadron Collider's goal is to recreate the small Big Bang. He was right, a miniature version of the very event that gave birth to our universe. The physicist elaborated further on the repercussions of this objective, highlighting the LHC's extraordinary potential for revolutionary discoveries. This includes its ability to unlock the secrets of the Higgs boson and probe dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine harnessing the power of creation itself, the capacity to call forth the essence of the universe. It's an enticing possibility, but one that is laced with risk. The miniature Big Bang isn't merely a theoretical idea, but a very real occurrence at the LHC. The pressures, temperatures, and unprocessed energy involved mimic the conditions of the universe's inception. It's like standing at the dawn of history, witnessing the very beginning of existence. But with power comes responsibility, and concern about what would happen if something went wrong. In fact, something did go wrong. Back in 1978, Russian physicist Anatoly Bugorsky had a life-altering experience. While working at U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, he accidentally placed his head in the direct path of a proton beam. The beam, with unimaginable energy, passed through his skull, entering from the back of his head and exiting through his nose. Bugorsky described witnessing a flash brighter than 1,000 suns, but felt no immediate pain. The beam's path left a trail of destruction, burning both bone and tissue. Despite this, he remained conscious and even walked to the medical center for treatment. The aftermath was both disturbing and surreal. The beam caused damage to specific tissues, resulting in partial hearing loss in one ear and facial paralysis. Remarkably, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the enormous power and potential dangers associated with particle accelerators. The dangers of an instrument like the LHC should not be underestimated. Concerns about catastrophic reactions and the alteration of life's fundamental fabric are not mere science fiction, but real suggestions made by well-known scientists. One of the most unsettling concerns about the LHC experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are enormous vacuums that consume stars, enigmatic entities lurking in the shadows of our universe. The idea that the LHC could potentially create one of these phenomena, even on a small scale, is both inspiring and alarming. Could such a black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and vanish almost instantaneously. Nevertheless, the remote possibility has sparked debate, anxiety, and a sense of wonder about the power we wield. To understand how the LHC could create a black hole at all, it comes down to the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is immense, so immense, in fact, that it can mimic the energy densities present during the universe's earliest moments. This concentrated energy, when put into a very small volume, results in conditions under which theoretical predictions point to the formation of a tiny black hole. However, according to Hawking radiation theory, such black holes would evaporate almost instantaneously, releasing particles and energy as they disintegrate. This theoretical safety net provides reassurance to many scientists. Yet it remains a topic of ongoing debate in the physics community. Despite reassurances, the mere idea of creating black holes or probing such extreme realms of physics is a double-edged sword. It speaks to humanity's insatiable desire to comprehend the universe, but it also demands that we confront uncomfortable questions about the ethical implications of such experiments. If the LHC holds the potential to create phenomena capable of altering the very fabric of spacetime, what safeguards should exist to ensure our pursuit of knowledge does not exceed responsible boundaries? Can we accelerate particles to near-light speeds and recreate the conditions of the early universe, pushing the boundaries of what is possible? As with each advancement, the goal of knowledge comes with risks. Despite scientific advancements, the dangers must be considered carefully, and safety protocols must be rigorously employed. Reality itself, from the nature of time and space to the origin of consciousness. As we delve deeper into the microcosm, the line between science and philosophy begins to blur. What began as an ambitious project to study subatomic particles may, in time, redefine how we perceive our existence. The discovery of the Higgs boson in 2012 was only the beginning. Scientists now hope to probe further into dark matter, dark energy, and even the possibility of extra dimensions. If these exist, they could offer explanations for long-standing mysteries, such as why gravity is so weak compared to other fundamental forces or whether parallel universes could be a reality. But with each new step, we are reminded of the delicate balance between exploration and caution. There are voices, even within the scientific community, that urge humility. They warn of unforeseen consequences, not because they doubt human ingenuity, but because history has shown that powerful technologies often bring both enlightenment and danger. The LHC is a symbol of humanity's brightest intellectual ambitions, the pursuit of knowledge for the sake of understanding. But it is also a mirror, reflecting our deepest questions, fears, and dreams. It forces us to ask, if we had the ability to unravel the very threads of reality, should we? And more importantly, are we ready for what we might find? As the collider roars back to life for its next series of experiments, these questions grow louder. In the tunnels beneath the Franco-Swiss border, where particles race close to the speed of light, we are not merely smashing protons, we are knocking on the door of creation itself. And whatever answers lie beyond that door, one thing is certain, the universe is listening. Everything from the smallest particles to the vast expanse of the universe itself. However, with such powerful tools at their disposal, scientists are well aware of the obligation that comes with expanding one's knowledge base. The LHC's capabilities make it one of the most advanced instruments ever built, capable of simulating conditions similar to those just moments after the Big Bang. This opens the door to a deeper investigation of quantum mechanics, the Higgs boson, and dark matter, key components that may explain the origins of the universe and the forces that shape its evolution. Yet this power also raises fundamental ethical and philosophical questions. If the LHC were to unlock new dimensions or create unknown phenomena, what are the broader repercussions? Could our search for knowledge accidentally lead to unforeseen risks, altering the balance of nature or triggering catastrophic events? Questions like these cannot be answered easily, and the answers may be elusive for some time. The scientific community continues to be wary but also optimistic. The potential rewards of the LHC's research far outweigh the risks. We are standing at the precipice of a new era in physics, where the veil of mystery surrounding the universe may begin to lift. The LHC is a symbol of humankind's eagerness and determination, demonstrating our desire to understand the cosmos at its most fundamental level. Ultimately, the Large Hadron Collider is not just a tool for scientific advancement, it serves as a symbol of human endeavor. It represents our collective desire to push beyond the known, to seek answers to questions that have long puzzled us. Whether it's unlocking the secrets of dark matter, gaining new perspectives, or simply expanding our understanding of the universe, the LHC is a reminder that, despite the risks, humanity's quest for knowledge is a necessary component of our development. As we advance, the inquiries will center on this new frontier. Discoveries will keep expanding, and so will our understanding. The LHC's journey is far from over. With each experiment, we are one step closer to understanding the universe's deepest mysteries. While the road ahead may be uncertain, the potential for discovery is limitless, and the pursuit of that knowledge is perhaps one of the most important endeavors humanity can undertake. As the Large Hadron Collider continues its groundbreaking work, it also brings questions that extend beyond the realm of pure science. While the potential for revolutionary discoveries in particle physics, cosmology, and quantum mechanics is significant, the ethical ramifications of these tests are becoming more and more apparent. As humanity pushes the moral boundaries of knowledge, the responsibilities of those conducting research with such high stakes cannot be ignored. The LHC not only explores the nature of the universe at its most fundamental level but also confronts us with inquiries regarding our place in the cosmos. In a sense, the LHC represents the cutting edge of scientific thought. It embodies humanity's insatiable curiosity and desire to conquer the unknown. Yet it also highlights a crucial paradox. The same instrument that could provide the most profound answers about the universe's origins could also potentially cause unintended consequences. The tension between discovery and risk is not new, but the scale and ambition of the LHC make these concerns particularly pressing. The LHC's experiments are based on the principle that, by understanding the very building blocks of matter, we can gain insights into the forces that govern the universe. However, these experiments delve into realms of physics that challenge even the most established theories. The creation of microscopic black holes, for example, provides a paradox. While theoretical models predict their rapid evaporation through Hawking radiation, the fact that this process remains purely theoretical means that uncertainties still linger. Could these tiny black holes behave differently than anticipated, with the potential for unforeseen consequences? As the LHC investigates phenomena like dark matter and the Higgs boson, it facilitates access to the possibility of discovering new forces of nature. The discovery of these unknown forces would forever change our understanding of the universe. However, the potential dangers of unlocking such forces are profound. Could they result in destabilizing existing structures of spacetime, or even the creation of environments that defy the laws of physics as we know them? While scientists remain confident in the safety of the experiments, the possibility of the unanticipated persists and casts a shadow over the LHC's legacy. In light of these risks, one might wonder whether it is responsible to continue conducting experiments that could alter nature's fundamental laws. However, it is essential to recognize that scientific progress is often achieved through exploration into the unknown. History is full of examples where the pursuit of knowledge has resulted in both positive and negative consequences. Yet, in the end, progress was made. With the LHC, the benefits of discovery may far outweigh the risks, provided that the proper precautions and ethical guidelines are followed. At the heart of this debate lies a fundamental question. Is humanity prepared to confront the potential consequences of its own curiosity? As scientists continue to investigate the darkest corners of the universe, they must strike a balance between the pursuit of knowledge and an understanding of the broader implications of their work. The LHC is not merely a tool for scientific advancement, it serves as a reminder of the responsibility that comes with exploring the unknown. It calls upon humanity to consider not just what we can discover, but what we should. This duality, the exhilarating potential for discovery versus the sobering responsibility of restraint, defines the spirit of modern science. The Large Hadron Collider stands at the center of this philosophical crossroads. As it delves deeper into the mysteries of the universe, it forces us to confront not only the boundaries of matter and energy but also the boundaries of ethics and foresight. Public engagement and transparency become increasingly important in this context. It is not enough for scientists to operate within closed circles, the broader global community must be invited into the conversation. The public must understand what is at stake, not just in terms of scientific triumphs, but also in the hypothetical scenarios that could emerge from probing the unknown. This raises a new imperative: education. As the LHC continues its work, there must be a concerted effort to educate people not only about the physics behind the experiments, but also about the principles guiding them, safety protocols, ethical frameworks, and the process of scientific peer review. Such understanding builds trust and ensures that exploration is not driven solely by ambition, but by collective wisdom. In the end, the Large Hadron Collider may uncover particles or forces that redefine our reality. It may validate or dismantle long-held theories. But beyond its scientific impact, it will also be remembered for how it challenged us as a species, not just to seek, but to reflect. Not just to explore, but to ask why, and at what cost. Its legacy, therefore, will be shaped not only by what it finds in the deepest layers of existence, but by how humanity chooses to interpret and act upon those findings. The LHC is a reminder that the pursuit of knowledge is never isolated from the human experience. It is a mirror reflecting our highest aspirations and our deepest concerns. As we look toward the next phases of research, possibly with even more powerful colliders or quantum computing integrations, we must hold fast to the lessons learned here. The universe may be infinite, but our time and resources are not. Our curiosity is boundless, but our decisions must be tempered with care.